Hello, everyone. Today we are going to talk about scatter plots, independent and dependent variables, and a correlation coefficient. We're going to start off with some definitions here. So a scatter plot is a statistical graph that shows a relationship between two variables. As we go through these definitions, if you need to pause the video and take good notes, that will be great. So on our scatter plot, we're going to have an independent variable. That's the variable on the x-axis. We're also going to have our dependent variable, which is the variable on the y-axis. We're going to talk more about correlation coefficient in a few minutes. We'll come back to that. So we're going to start off here by creating a scatter plot. We are given here some data, two variable data, and our independent variable is the temperature. This is our x-axis. Okay, this is our temperature. So the temperature in the day and our dependent right here are the snow cones sold that day. And we are going to, that's our y, that's our independent, and it's on our y-axis. So we're going to go ahead and create the scatter plot by graphing these points. We're going to graph this 65 and 20. So 65 degrees, the day it was 65 degrees, they sold 20 snow cones. When it was 70 degrees, on a day they sold 25. That would be about right there. On another day it was 70, they sold 35. Okay. Then there's a day that was 80, they sold 40. And at 85 degrees, 45. 90 degrees is 60 right here. Another day was 90, and that was sold 75. And another day was 95, and that was 80. So here we have, this is called a scatter plot. And we are looking at, is there a relationship between the temperature in the day and how many snow cones sold? And as we look at this, you can tell that there is a relationship here. The warmer it was, the more snow cones sold. And we're going to talk about that today on these, looking at scatter plots and looking at their relationships. So let's go on here. Here we have another scatter plot that's already on here for us. This one, our independent variable, is the minutes studying for a test. And our dependent was the number of questions missed on the test, okay? So the number of questions missed depended on how many minutes you studied for the test. So let's look what we want to do here. This is already given, the data is already put on this graph. So I went ahead and we can see that there's a relationship here. This is actually the data looked like these dots were moving negatively towards like a downward slope. And that's what we're looking for when we're looking at statistics, is the relationship. Is it positive? Is it negative? We're going to talk more about that in a minute. But here I drew a line through here that was the line that kind of best matched. They call it the line of best fit through this data. And let's go ahead and write what the coordinates are for these red dots, because we're going to actually write the equation of the line that best fits this data. So these dots here, the red ones, let's look here. Let's actually write them over in our table. This is 20 as our X value, 20 minutes, and then there were 7 questions missed for only studying 20 minutes. Oh, and over here, somebody who studied 80 minutes, there were only three questions. Whoops, write that a little bit better. So for 80, there were only 3 questions missed. So we're going to write, this is what we've been doing on our last assignments. We are going to write the equation of the line that goes through these 2 points. So first of all, we know we need to find our slope. Our slope is the change in y. What is happening here? To go from 7 to 3, we are subtracting 4. Our slope is the change in y over the change in x. What's happening to go from 20 to 80? Well, we're adding 60. And remember, it's the change in, we're going to slide this over here and divide. So our slope is negative 4 over 60, which reduces down to, well, you can look at it. If you see this way, that would be negative 2 over 30, but that keeps going. That reduces down to negative 1/15. Okay. You could also put that in your calculator if that will help. So our slope is negative 1/15 over 15. To write our equation of our line, we need to choose one of our points. I'm going to choose the 20 minutes or 20 minutes studied and 7 questions missed. There are 27, that point. And I'm going to simplify now. So we've got some fractions here. That's okay. You're welcome to use your calculator, or I might go through these fractions individually here to practice that. Negative 1/15 times x is negative 1/15 x. Okay, that's a 5. Then we're going to have our negative 1/15 times 20. Well, negative 1/15, 1 over 15 times, and it's negative 20. Remember, that's like it's over 1. You multiply your numerators, and negative times a negative is a positive over 15. Does 15 over 20, does 20 over 15 reduce? It does. You can divide a 5 out of both of those and get 4 over 3. So negative 1/15 times negative 20 is positive 4/3. And we're going to add that with 7. You are welcome to do all of this on your calculator, but I'm going to go through it with fractions to give us practice of that. When we're adding fractions, we are going, the 7 is over 1. Okay, we need to get a common denominator. What's a common denominator between 3 and 1? Well, it would be 3. So we're going to multiply both by 3. So our equivalent fraction to 7 over 1 is, another way would be 21 over 3, because 21 divided by 3 is 7. So that's an equal number. Well, 4/3 plus 21/3 gives us 25/3. All right, I'm going to write this now as our final equation. Here is y equals negative 1/15 x plus 25/3. It's all right. Use your calculator if you need help with the fractions. But that is the equation of our line. Is what we've been learning to do. The equation of the line that goes through these 2 points. I have another question for us, and some questions will be like this on your homework. So now that we have the equation of our line, if we use this equation of the line to answer this question, how many minutes of studying do we need to not miss any questions? To miss 0 questions, how many minutes do we study? What would that be? Well, let's see. How many minutes studying? So we're trying to figure out this minute studying. That's our independent variable. That is our x. We're trying to figure out our x. So we want to figure out what x is to miss 0 questions. Well, our 0 questions, that's our independent. That's our y value. So we're going to put our 0 right in here for y. Let me move some things around here a little bit. So if we put a 0 right in here, I'm going to use red, I guess. 0 right in here for y. And we are going to now solve for x. We have fractions here. This is going to be a good fraction assignment or a page to do. You're welcome to use your calculator. But I'm going to go through here and do it so we can get some fraction practice. So we're going to subtract 25/3 from both sides because we're solving for x. 25/3. Here's our force field. So we're going to subtract 25/3 from both sides. So we have let me move this out of the way. So 0 minus 25/3 is negative 25/3, and that equals 1/1000. that was a negative. We can't forget that. Negative 1/15 x. And 25 thirds minus 25 thirds went to 0. Okay, now we have our x's being multiplied by negative 1/15. Remember, when we undo multiplying, we are going to divide. When we divide fractions, so we are going to divide, we could write it like this. We're going to divide both sides by negative 1/15. We're going to divide over here by negative 1/15. That looks kind of crazy messy. When I like to divide fractions, we know over here we're going to be left with our x. But when I like to divide fractions, I write them out. Negative 25 thirds, and we are going to divide by negative 1/15. That's what we're doing here. I'm just rewriting it onto the side here. So, whoops. We have our negative 25 thirds divide negative 1/15. When you're dividing fractions, if you can remember, you keep the first fraction the same, keep, change, flip. Change divide to multiply, and you flip the second fraction. Do the reciprocal. All right, so you can do this on your calculator. You can do it by hand, whatever you want. But I can see here that 3 goes into 15 5 times, and negative 25 times negative 5 is positive 125. So positive 125 equals our x. That equals our x. So 125 minutes is what, using this equation, you would maybe need to study in order to not miss anything on the test, on this data for this test. Okay, now we're going to go back on and start describing our scatter plots. Okay, there's two important things when we need to describe a scatter plot. We want to look at it if it's positive or negative, what type it is, if it's positive or negative, and we want to see the strength of it. Okay, so looking at this scatter plot right here, okay, we see all these dots on this thing. Looking at, you can still see that as these dots are going, they're still kind of moving generally in a negative direction down here. So we're going to know that this one is a negative. We've described this as a negative relation. As these dots, as the independent variables get bigger, the dependent ones are getting smaller. So that's a negative scatter plot. Now we also need to say, do we think that the relationship is very strong, moderate, weak, or very weak? Right now, we're kind of like, this is kind of a guess here. So looking at this, a very, very, very strong one would be a straight line going down there. And so this is, maybe my guess is moderate to strong, maybe. We're going to talk about more of this in a minute. I would probably say that's maybe on the high, moderate, or the strong. We're going to talk about being more exact in a minute. So the next one here, our description. Oh, so this one, we're looking at this one. This is positive. Oh, so if we need to write a description, we would write positive. We can know that one. And this one kind of looks like that's a pretty good relationship. As the x values are getting bigger, the y values are getting bigger. As our independent variables getting bigger, the dependent ones are. There is a pretty good relationship here. So I would call that strong, but maybe not quite very strong. So let's do another one. Oh, can we even tell on this one if this one is positive or negative? This one actually, looking at it, we can't tell at all. So we would call this that this has no correlation. And we're going to talk about a little more here. Oh, this one looks like this is definitely positive, right? So we write our positive. And looking at this one, I would call this one very, very, very strong. So very strong. We're going to be more exact with these in just a minute here. So we're going to talk that there's actually talk about that there's actually a number is assigned for that correlation. That number is called the correlation coefficient. And there's a number as you entered this data into a calculator or a graph that we would come up with a number here. And we're going to learn how to do that next week. But right now, let's define this. The correlation coefficient is a number between -1 and 1 that describes the type and the strength of a relationship of two variable data. That number is between -1 and 1. So we're going to look at a chart here. So the correlation coefficient, look at this. So if there's no correlation, that number is going to be 0. So that one that didn't have any correlation, that would be 0. Okay. So our negative, if there's a negative correlation, we're going that to the left. If it's a positive correlation, it's going to the right. Okay. But this just showing you that this chart shows it for us. And the numbers are between, if you can read that over here, this is -1. Can you see that number good enough? And over here is +1 right here. So a very, very strong, the strongest would be +1 correlation in the positive. The strongest in the negative is -1. So we're going to practice, if you like, looking at those graphs. We could have given them numbers. I'm going to now just tell you, say we had a correlation coefficient with a 0.3. Where does 0.3 fit on this graph here? Look over here and we're coming along and we see, oh, 0.3 would be right here. Okay, so if we had a scatter plot that had some two variable data that had a correlation coefficient of 0.3, how would we describe that? Well, we would describe it as positive, and right here, the 0.3 is weak, positive and weak. So if you had a correlation coefficient of 0.3, it's positive and weak. Let's do another one. Say our correlation coefficient is a -0.65. Well, we know -0.65 would be right, let's see, right there, because that would be negative. So that gives us, if we describe it, remember we know the type, that would be negative, and the strength over here is strong. So to describe a correlation coefficient of -0.65, it's a negative and has a negative and strong correlation. All right, I hope this helps you on your homework, and have a great day.